Another shonky phone footage video. So it's Bank Holiday Monday, early May Bank Holiday Monday here in the UK, and it has been, don't know if you can hear that, it has been blowing a gale and absolutely belting it down all weekend. I just had to sneeze there. So anyway, so many amps I got the other year. I've decided this little one is perfect for just a small valve amp. I've got some bigger cases over there, but they just seemed too big and wasteful. So I'd played around with these a few years ago. I've had these years. These are RS Components, they're Oxford Electrical Products Transformers, OEP, number N35A002F. They're single-ended universal valve transformers. So last time I used these, I had them on transistors. So anyway, I've been tinkering about in here today. These are some 6P15P. They're like very close to an EL84, but they're video output valves. This is a 6N2P. This is a Russian equivalent of a ECC8312AX7. So the circuit is running. I've got 6.3 volt filament transformer and a dual 55 volt toroidal transformer. That's running voltage doubler, giving me about 340 volts. By the time it's gone through this lot, I've got about 300 volts on the anode. I've got a 10k resistor and a filter cap and 2k2. I've got about 220 volts on grid 2. I got a 330 and a 470 ohm in parallel in the cathode, giving me about 200 ohms. About 6 volts on the cathode, so I'm pulling, I can't remember what it works out, like 25 milliamps or something. A bit more filtering, a 10k, and then another capacitor for the HT for the 6N2P. 200k anode load resistors in the 6N2P. 4k7 cathode resistors. The feedback is coming via a 10k resistor that goes into the cathode of the 6N2P, so you can see it joins in the middle between the two cathode resistors, feedback resistor. And then to stop the thing oscillating, I found 100 picofarads across the 200k anode load resistors. Makes it incredibly stable, and I mean stable. I can put 100 nanofarad cap across the outputs, doesn't bother it. I can disconnect the outputs without signal, doesn't break into oscillation. I seem to be a bit low on gain for my maths though, because with 10k feedback resistor, it's only actually reducing the gain by 9 dB, and I don't seem to have a great deal to start with. So yeah, I mean, phone signal's not the best, loudest of things in the world, but it's only really pushing it, I'm probably peaking at about 1.5 volts each way when I crank the phone flat out. So I've got to get my frequency tester on it, just see how it's behaving, you know. But yeah, it's running anyway. I can't get my head around the phasing. So right, signal goes into the first valve. Let's say the signal's going positive, the anode goes negative. That's driving the gate negative on this valve, which therefore means the anode goes positive, and you follow the wires, they're going to this side of the transformer, which means if that side's going positive, you'd think it was the same this side, but it isn't. The transformer, look, 1 and A are at opposite ends, so when I first tried to apply feedback, I was just getting it oscillating. So yeah, C is actually my feedback tap. So A, both the A's are tied together and they're going to 0 volts, and C is going through my 10k resistors. I was getting a weird hum problem. It turns out I'm floating the heater. That's like a massive no-no on a valve amp. You don't float the heater, it induces noise. But with the heater floating... Oh, let's go on a more realistic scale. So like 5 millivolt scale. So you can see I've got 10 millivolts peak to peak of noise. And that increases significantly if I try to... Anyway, if I tried to if I tried to ground that heater, I've got it going through 200 ohm resistors. If I try at any point on this board, even right back to there, it's inducing noise. Now, I think that's down to the fact I'm using a voltage doubler. I reckon that because it's two transformers, I think it's actually capacitively coupling through the transformer, like secondary, primary, primary to secondary. Because I'm using a voltage doubler, I'm actually generating like 170 volts offset to the center point on the transformer. So I think that's where the noise is coming from. So yeah, I tried, like, you know, if you just to see if it was, if you tried bypassing one resistor and tapping 0V to that, it just made it worse. So a humbucker wouldn't help, because anything offset from the center point just made it worse. And admittedly, I know the wiring's a mess, but it is following the standard bus bar configuration, and it is dead silent, like you say, with 10 millivolts peak to peak. That's ear on the drivers before you can hear anything levels of hum, which is, you know, more than acceptable. So yeah, anyway, just a quickie, just to prove it does work. Let's get something off the YouTube library. Of course, there's going to be adverts. There's always adverts.
Enjoy more.
I don't want to enjoy more.
Right,
I don't want to enjoy it. I don't want to. Your video will play after your adverts. It's all right. We've only got to endure this for another 5 seconds. So yeah. So that's 500 millivolts scale. So you can see peaking about 3 volts peak to peak. So like 1 volt RMS or something. But that's all this phone's. I can obviously drive it hard with a better signal source. That's just all that phone will drive it to, but yeah. And it does sound very nice. Without negative feedback, it sounded horrible. It was very distorted. Just a mere 9 dB of negative feedback and some capacitors. I think it's transient intermodulation distortion without the feedback and without any frequency limiting components. It was just creating a lot of high order harmonics being single-ended pentos, which weren't nice. But yeah, that's it. It's working. So yeah, anyway, if you've watched this, it's another quick short from me. Next thing to do, this is getting built into that, so that is the next project. Because I don't want to be using that big ass Yamaha down there. I want a little workshop amp. And this is it. So yeah, hopefully should film some of it, I can be asked. But as always, thanks for watching and catch you next time.